students, so in the previous video we went over the pH scale and the pOH scale and how those relate to your hydrogen ion concentration or your hydroxide ion concentration. In this video we are going to go over how to actually calculate the pH or the pOH from your hydrogen ion concentration or your hydroxide ion concentration, and then go back and forth. In this unit, we're going to be using the log function on your calculator. So I'm going to show you guys how to use that. And hopefully those of you in Algebra 2 have been using that recently or getting ready to use that log function. So you'll see some similarities there between here and algebra. But when we use the log function, it's just the exponent to which we raise the base number. So on our pH scale, we go from basically 0 less than 0 to 14 or greater than 14. And that gives us a usable number that we can actually compare pH values from one substance to the next substance. If we're talking about the ion concentration, because they're times 10 to the negative 14 or times 10 to the negative 4, it makes it more difficult to compare those values. So putting it in terms of pH or pOH makes it a little bit easier to compare values. Now, one thing though, for this particular unit is that we're going to be using different sig fig rules. Okay, so when you're looking at the pH or the pOH, only the numbers after the decimal point are significant. So if a pH is 6.9, for example, that only has one significant digit because there's only one number after the decimal point. So if we're trying to convert from an ion concentration to a pH or a pOH, the total number of sig figs in that concentration are the number of digits we have to have after the decimal point in our pH or our pOH. And I'm going to explain this more as we go along. Okay, if we're trying to convert from a pH or pOH into an ion concentration, the number of digits behind the decimal point are going to be our total number of sig figs in that concentration. If we're just going between pH or pOH, or if we're just going between hydrogen ion concentrations and hydroxide ion concentrations, we don't really have to worry about changing sig fig rules because normal rules would apply. Before we get to our calculations, I just want to go over a couple of things. So when we're talking about acids, we can have monoprotic acids, diprotic acids, or triprotic acids, and that's referring to how many ionizable hydrogens there are. So monoprotic, the prefix mono means one, there's only one ionizable hydrogen, such as HCl. A diprotic acid means that there's two ionizable hydrogens, such as sulfuric acid H2SO4. And in a triprotic acid, there's three ionizable hydrogens, like H3PO4. Now, acids are only going to ionize one hydrogen at a time. So if we have phosphoric acid, H3PO4, it's only going to ionize that one hydrogen first, and you'll be left with H plus and H2PO4 minus. Bases, though, ionize everything completely. So they're going to break apart into that metal cation and your hydroxide ions. So if we're talking about strong acids and strong bases, the concentration of the acid or the base is referring to the concentration of the ion. Now with acids, because they only ionize one hydrogen at a time, the concentration of the acid is equal to the concentration of that hydrogen ion that we need to do our calculations with. With bases though, we have to multiply that concentration by the number of hydroxide ions in solution. So if you see here, we have two examples, sodium hydroxide and barium hydroxide. Let's say that we have a 1.5 molar solution of both of those. Well, in that sodium hydroxide, if it's a 1.5 molar solution, we would have a 1.5 molar solution of hydroxide ions because it's ionized completely. But in that barium hydroxide, we would have 3.0 molar hydroxide ion solution because when it ionizes completely, there's twice as many hydroxide ions as there were for one barium hydroxide formula unit. Okay, so you would have to multiply that concentration by the number of hydroxide ions in the solution for strong bases. All right, so we're going to go to our calculations. So I'm going to go ahead and share my packet here. I want to be able to let me switch my view here. I want to be able to show you guys my calculator as we're working. So we're going to start with this first little bit here. Let me go ahead and try to zoom in. Okay, so our first calculation is going to go back and forth between pH and hydrogen ion concentrations. Okay, so we're going to be using a negative log to go from our hydrogen ions to our pH. Okay, so remember the concentration of the solution is going to be equal to the concentration of the hydrogen ions. So here we're trying to find the pH, and here's our hydrogen ion concentration. Now we have 2 sig figs here. That's going to become important in our answer. So I'm going to go ahead and put negative log, here's the log next to the 7, of my concentration. So 1 second E negative 4. And that's going to give my answer. Now, because I have 2 sig figs and 1.0, I want 2 sig figs for my answer. And so my answer would have to be 4.00. This next example, it's the pH of, remember this is hydronium and hydrogen are the same things. I've got 2 sig figs again. So that means I need 2 numbers after my decimal point and my pH. So I'm going to have negative log and 2.1 second E negative 13. So my answer rounded to the correct number of sig figs would have to be 12.68 because I need to have 2 numbers after the decimal point in my answer. What's the pH if my hydronium ion concentration is 1.0 times 10 to the negative 5th? Anytime I'm given the hydrogen ion concentration, I would do negative log, then my concentration, so 1 second E negative 5, and my answer would be 5. Now, how many numbers do I want after my decimal point? Well, I've got 2 sig figs here, so I'm going to have 2 numbers after my decimal point, so I'd have to put 5.00. Same thing over here on this side. The pH, if the hydronium ion concentration is 3.44 times 10 to the negative 4, I'm going to have negative log 3.44 second E negative 4. Now I've got 3 sig figs in this case, so I want to have 3 numbers after my decimal point. So my answer would be 3.463. Here, the pH of the hydronium ion concentration is 7.49. If I'm given the ion concentration, I do negative log 7.49 second E negative 11. And I've got 3 sig figs total, which remember that has to go after my decimal point. So I have 10.126. Sorry, my light up here keeps flashing, so I'm just going to go ahead and turn this. I don't know why it keeps flashing like that. Then last one here, negative log, if I'm given the ion concentration, 2.57 second E negative 7 to find my pH. I've got 3 sig figs here. So my answer would be 6.590. Okay, now next thing it says label each of the above as neutral, acid, or base. So remember, if it has a low pH less than 7, it's an acid. So that one's an acid, this one's an acid, this one's an acid, and this one's an acid. If it has a high pH greater than 7, it's going to be a base. So this is a base, and then this one over here is a base. What do I notice about the hydronium ion concentration of all of the acids? It is greater than 1.0 times 10 to the negative 7. And the bases, it's less than 1.0 times 10 to the negative 7. All right, let's go ahead and do this next one. So this next one, very similar, but this time it's the POH and the hydroxide ion concentration. So I just want to make sure you guys are aware that if I've got hydroxide ions here, I'm going to get the POH here. if I'm taking the negative log of hydrogen or hydronium, I'm going to get the pH. So the ion concentration is going to match up with the scale that we're talking about. So here, the POH, if hydroxide is 1 times 10 to the negative 4, so I'm still going to go, sorry, I don't know why this isn't working. Negative log of 1 times 10 to the negative 4. I've got 2 sig figs. Let me just go ahead and highlight that. I'll highlight all 3 of these ones here. And my answer is 4. So that means I have to have my answer is 4.00 because I've got to have 2 numbers after my decimal point. The POH, if the hydroxide ion concentration is 5.111, so I have negative log 5.111, second E, negative 6. So I need to have 4 numbers after my decimal point. So my answer would be 5.2915. And then here, the POH, see, I'm still doing negative logs because to get from the ion concentration to the pH or the POH scale, I just have to do negative logs. I need 2 numbers after my decimal point, so my answer would be 2.54. Over here, what is the POH? It's the hydroxide ion concentration. Again, I'm going to do negative log because I'm starting with ion concentration, 3.99, second E, negative 12. I want to have 3 sig figs behind the decimal point, so my answer would be 11.399. Next, it's the same thing. It's going to get repetitive, 4.38, second E, negative 8. I've got to have 3 numbers after my decimal point, so my answer would be 7.359. And then the POH, if my hydroxide ion concentration was 8.76, so I'm still doing negative logs, negative 7. 3 numbers after my decimal point, 5, 7. All right, so then, what is the difference between pH and POH? Well, pH is going to measure our hydrogen ion concentration, while the POH is going to measure the hydroxide ion concentration. And remember, these are inverse. So if the pH is low, that means the POH is going to be higher. If the pH is higher, the POH is going to be lower. So these are opposites of each other. So in this case, when we're trying to label each of the above as acid, neutral, or base, the acids are going to have a higher POH. So this one's going to be an acid, and this one's going to be slightly acidic. Whereas the rest of these are going to be bases, because bases are going to have a low POH because they have a lot of hydroxide ions in solution. Okay, so then let's look at this next set here. This set's going to be easy because it's referring to the scale of pH and POH. And like I just said before, these are opposites of each other. They're both a scale out of 14. So we just have to add them together and they would equal 14. So if we subtract 1 from 14, we're going to get our answer. So we don't have to change any of our sig fig rules. Our sig fig rules would apply. So this is going to be 8 here. This is going to be 11.0 when we're adding and subtracting. We got to keep the same number of sig figs after the decimal point. This one is going to be 7.00. This one is going to be, I don't trust my mental math right now. It's been a long day. 9.89. This one will be 3.00. I'm just subtracting these from 14. And then this next one is going to be 8.57. So when we're trying to label these as a neutral acid or base solution, it might be easiest for you in terms of the pH, because I know that if pH is low, it's an acid, but if pH is high, it's a base. If pH is 7, it would be neutral. So here the pH is less than 7, so it's an acid. pH is less than 7, it's an acid. pH is greater than 7, that's a base. Okay? So our next set is when we are going to try to find our ion concentration. Okay, we're trying to find our ion concentration. So this is where we're given the pH or the pOH. Now remember, these have to match. So if I'm given the pH, I would be finding the hydroxide ion concentration. If I'm given the OH, I would be solving for the hydroxide ion concentration. Now this is going to be 10 to the negative pH or 10 to the negative pOH. I kind of accidentally X that out on my thing here. Let me try to adjust this focus a little bit here. Okay. So what I do on my calculator is that I am going to do the second log, because if I do second log, it pops up with 10 and the exponent right here. And then don't forget your negative sign. You gotta put that negative in, -3. Now this is the pH, so it's gonna give me my hydrogen or hydronium ion concentration. I've gotta have 2 sig figs, because remember when I'm looking at the pH or the pOH, the numbers after the decimal point are significant, not the numbers in front of it. So to round this to 2 sig figs, my answer would be 0.0010. Now concentrations are going to end and have a unit of molarity. So I'm going to put a big M behind that answer. Next question, what's the hydroxide ion concentration at the pOH is 6.73. Anytime I'm given the pH or the pOH, I'm trying to find ion concentration, I can just do second log. That gives me my 10 to the negative 6.73. And this is pOH scale, so it's going to give me my hydroxide ion concentration. And I've got to have 2 sig figs, so I would record my answer as 1.9 times 10 to the negative 7. Now I'll put a big M on my concentrations. The pH and the pOH do not have units. Next, what is the hydronium ion concentration of the pH is 13.11. So if I start with pH, I can do 10 to the negative, so second log, negative 13.11. Again, I'm going to have 2 sig figs here. So my answer would be rounded to 7.8 times 10 to the negative 14 M. What is the hydronium ion concentration if the pH is negative 0.158? So this time, 10 to the negative is, it means I have a positive, so 10 to the 0.158. I'm just not going to put that negative sign this time. I've got to have 3 significant figures, so my answer would be 1.44 molar. Over here, what is the hydroxide ion concentration if the pOH is 14.37? I've got 2 sig figs on that one. So I would have 10 to the negative 14.37. I want to round this to 2 sig figs. So my answer would be 4.3 times 10 to the negative 15 molar. Now this time I'm going to have trying to find the hydronium ion concentration and the hydroxide ion concentration. So let me just write these both here. Hydronium ions and hydroxide ions. Now if I take my 10 to the negative 8.5, is that going to give me hydrogen ions or hydroxide ions? Well, because this is talking about the pOH, this is going to give me my hydroxide ion concentration. So my answer for the hydroxide ion would be 3.2 times 10 to the negative 9. Now I can find my hydronium ion concentration by using my equilibrium constant of water, which is 1 times 10 to the negative 14. So I can take my 1 second E negative 14 and divide it by my second answer, and I would get my hydronium ion concentration of 3.2 times 10 to the negative 6. Okay. All right, so then we're going to do some mixed practice here. So we're trying to find our POH, but we're given hydronium ion concentrations. So what I'm going to do, there's a couple of different ways that you can solve for this, but I always like to go back and use the pH plus POH equals 14 because that's the easiest thing to do. I'm going to first take a negative log. So if I have ion concentration, I can do a negative log of that 5 times 10 to the negative 6. Now this is not my answer because since this is hydronium, this is going to give me my pH. And then if I do 14 minus that answer, then I would get my POH. And I want 2 sig figs, so behind the decimal point. So my answer would be 8.70. In this next one, I'm trying to find my pH, and I'm given my hydronium ion concentration. So I can take my negative log of 2.53 second E negative 4, because this is hydronium ions or hydrogen ions, that is going to automatically give me my pH value. I don't have to do anything else on this question. I want 3 total sig figs, and because this is, I'm solving for my pH, those sig figs are going to come after my decimal point. So my answer would be 3.597. Remember, pH and POH do not have units. Next, I'm starting with my pH, and I'm trying to find hydrogen ion concentration or hydronium ion concentration. So if I'm given the pH, what I can do is my second log, so it's 10 to the negative 4.921. I've got 3 total sig figs, so I want 3 sig figs in my answer. Oh, and see what I did wrong? I forgot to put the negative sign there. So I want 10 to the negative 4.921. So I want 3 total sig figs like I was saying. So my answer would be 1.20 times 10 to the negative 5. And that would be a big M for my units. Here I've got POH, and I'm trying to find hydroxide ions. So this is going to be just a single step problem because the scale and the ions match. So again, if I've got the POH, I can do 10 to the negative 8.31. I want 2 total sig figs, so my answer would be 4.9 times 10 to the negative 9. Okay. Over here on this side, I've got a pH scale, and I'm searching for hydroxide ions. Now in this case, because the ion doesn't match the scale, I'm going to have to do 2 steps to solve for this. So the first thing I'm going to do is I'm going to do 14 minus 9.29, and that's going to give me my POH. Once I have my POH, then I can do 10 to the negative 4.71, and that would give me my hydroxide ion concentration. Now, how many total sig figs do I want for this one? I want 2 total sig figs, so my answer would be 1.9 times 10 to the negative 5. Here, I've got hydroxide ion concentration, and I'm trying to find pH. So is this going to be a 1-step or a 2-step problem? It's going to be a 2-step problem because the scale and the ions do not match. So I can do this 2 different ways. Let me show you both ways to show you it doesn't matter which way we do this. So the first way, I can use the equilibrium constant for water, 1 times 10 to the negative 14. And I can divide that by my hydroxide ion concentration, and that's going to give me my hydrogen ion concentration. And then if I get my hydrogen ion concentration, I can do negative log of that answer, and I get 12.553. The other way that I can do this is I can start with the negative log of the hydroxide ion concentration. So I can start with negative log of 3.57 second E negative 2. Now this is going to give me my POH because this is hydroxide ion concentration. And if I subtract this from 14, you'll see that I get the same answer that I got up here. So either way you do that, it's up to you, whatever you find the easiest. Here, I've got POH, and I'm trying to find hydronium ion concentration. Again, this is going to be a two-step problem because the scale and the ions do not match. I can do this two different ways. I'll show you both ways. I can do 14 minus my POH, and that's going to give me my pH of this solution. So that's my pH. Once I have my pH, I can do 10 to the negative 2.37 to get my hydronium ion concentration. And so that answer would be 0.0043. The other way that I can do this is I can do 10 to the negative POH, 11.63. Now this would not be my answer because this would give me my hydroxide ion concentration. But what I could do from there is use my equilibrium constant for water, 1 times 10 to the negative 14, divide that by my answer, and you can see that I get the same value for my hydronium ion concentration. So whichever way you would like to do that. Here, I've got hydroxide ions, trying to find hydronium ions. The easiest way to do this is to use my equilibrium constant for water, 1 times 10 to the negative 14, divided by my given ion concentration of 4.76, second E, negative 10. And I've got 3 sig figs, so 2.10 times 10 to the negative 5th would be my answer. Okay? So if you guys have any questions at all about how to do your pH calculations or how to do the sig figs, just go ahead and let me know. All right, I'll talk to you all later. Bye.